Welcome back to our live training session. In this training module, we're going to be expanding upon our base map creation process that we began in the last tutorial. Now we're going to be digging in how to set up the actual table configuration for our Motec M150 using a Honda K series engine. Now, we're going to go through taking a look at one small detail that we left off with in that last training module. That was making sure that our fuel temperature table was populated correctly in terms of the axes and the values within the table. Let's talk about that first, because again, that's something I wasn't 100% sure of off the top of my head in the last training module. So coming in here, we're gonna make sure we complete that process. So now then, all the inputs and outputs have been configured properly. So let's jump in here and take a look at that translation table. Moving from our tuning window right here, we're gonna jump down under setup and then move into our advanced inputs. Recall that we have a flex fuel sensor installed on our vehicle here in our fuel system. We've wired it to the Motec. So we've wired the signal into digital input 8, universal digital input 8 in fact, and we're gonna find in this case, taking a look down here, the fuel temp translation table. This is going to be set to the configuration for a GM Continental style sensor, pretty much the standard for ethanol content sensors that are on the market. We're going to find the table actually should be 1 volt and then 5 volt. And then at 1 volt, it's -40 Celsius, and at 5 volts, it's 125 Celsius. Now, you may have to go in here and configure a few things. I've actually went in here, if we go here and do a right click, go to import, go to from CSV file. Within our table import CSV, that's found in our training course folder, I've given you some sample CSVs that you can import. This is going to be included within their fuel temperature sensor translation. We select that, it automatically populates the table for us. We don't have to dig in and remember exactly what I said in the tutorial. You can just do that at any point in time and bring that data into your file. So that is something we've taken care of. And once we upload the file to the vehicle and get on the online status in the next training module, we'll verify that it is reading correctly. But this is going to be what we should have for the translation scale. So the old scale that was in there was definitely inaccurate. Okay, let's jump in now and talk about what we're trying to accomplish in this training module. We need to set up all of our 2-dimensional and 3-dimensional tables for programming. So we've set up all of our basic details, inputs and outputs. Those are some of the fundamentals that we have to get out of the way. The next thing is when the engine actually fires up and runs, how it's going to be using the values within our table, such as the engine efficiency table, which is the volumetric efficiency table, the lambda aim table, which is our target lambda table, spark timing table, idle control, making sure that these variables are set up correctly so that we have a better chance of getting the engine to fire up and run properly for our specific application. So again, we're naturally aspirated, and the base file that we're starting off with here from Motec was centered around a Subaru engine. It's not going to be relevant for my naturally aspirated K series engine. So let's dig in here and take a look at setting up our tables and making them more specific for our application. So first and foremost, we're going to start off here under our tuning page, going here under fuel tuning. We're going to work our way across from left to right, going through each individual screen. We'll go ahead and make sure everything is configured properly here. So fuel tuning. First thing we have here is our engine efficiency table. The engine efficiency table is our volumetric efficiency table. This expresses the percentage of cylinder filling at a given RPM and inlet manifold pressure. This essentially is estimating the air mass or airflow coming into our engine. If we had a mass airflow, this would be actually measuring then from a mass airflow sensor that amount of air mass or the airflow coming into the engine. So we need to go put values in the table here that make sense for a starting point. Let's first go in here and change our breakpoint values that are going to better represent a naturally aspirated engine, also making sure we're accounting for the engine RPM we plan on revving our engine to. We can see this table here is going out to 8,000 RPM. I plan on potentially revving this engine out to 9,000, so we need to do some breakpoint modifications within our table here. Let's take a look at how to do this. We're going to click A here on the table, and now we're able to access the breakpoints for editing that we can see on the table here. So first thing we find is engine speed. We can see the enable axis is toggled on. That's our top axis here. We're finding the table goes from 0 to 8,000 RPM. Let's go here to clear table, click yes, and then I'm gonna go to generate. I'm gonna start the table at 0 RPM and then have my last value at 9,000 RPM. We'll go in 500 RPM increments. Now we have 40 total available breakpoint sites in the table. We're only using 19. This is saying that we have extra resolution that we can add additional breakpoints if we choose to do so at any point in time. And we might have to, depending on what it's looking like in terms of our fueling. If we're finding we have a resonance spot at a certain RPM point, that's where we have more of a wave charging from our intake and exhaust combination, we may have to kind of hone in on that so we can fine tune that area so the fueling is a little bit more accurate. This resolution should be a good starting point for pretty much any engine. Again, if you plan on revving your engine, I plan on probably topping it out maybe about 8,500. I want to go ahead and have my last breakpoint here in the table about 400 to 500 RPMs higher. That way, in case I plan on trying to rev it higher, I don't have to do a rescale or go back into this table and have more editing time spent. So I'm going to go ahead and make sure I'm taking care of all of that and already in the axes. Let's go to inlet manifold pressure. That's our left axis here. This is going to be our load input. The inlet manifold pressure, the map pressure sensor, is what we use in the speed density system in order to follow the engine load, so to speak, as we're going through and we're operating our engine. Now, this table goes out to 300 kPa. That would be fine for a turbo engine, but we're naturally aspirated. We're not going to get above approximately 100 kPa or atmospheric pressure. Now, I'm about at sea level, so we'll find that I'm probably going to be hovering here, key on engine off, right around about 98 to about 102 kPa. That's going to be the highest I can see in terms of airflow coming into my engine. Now, I do have a cold air intake on this, and I may get a ram air effect at speed as I'm driving my vehicle, let's say going down the drag strip or on the track. So I want to be able to scale a little bit higher than the maximum pressure range I anticipate running my engine at. So if I know naturally aspirated, 100 kPa is theoretically sea level. If I have a ram air effect, I may start to generate a little bit of positive manifold pressure. I want to go in and probably scale that to about 120 kPa. So I need to go in and redo all of my axes. Let's go here to clear table. We'll say yes, clear that out. Go to generate. We're going to start here at 0 kPa. We're going to end at 120 kPa, and then we're going to go in 10 kPa increments. We have 24 total available sites. We're using approximately half of those sites. So we have more resolution than we can add. We really don't need to move in much finer increments than 10 kPa within this table here. So let's click OK. Now we do also find a table, or an axis I should say, we can add on here for ambient pressure. So if we're finding we're changing elevation, our ambient pressure will change, and that could affect our fueling. That might be something you want to enable. For right now, I'm going to leave it off. I don't plan on really operating my engine much here outside of sea level conditions. So I'll click OK, and now we can find we have a basic table structured around my engine in terms of the breakpoints that make sense, the resolution, as well as the engine speed. Now, what we're going to do from here, let's just go ahead and just take all the values in the table. We're going to clear them out. I'm going to put all the values to 100, just set the table kind of a generic value. Now we're going to go in here and be a little bit more specific of setting up the volumetric efficiency values that should make sense and give us a good starting point, regardless of whatever engine you're trying to calibrate and tune with your M150. So it doesn't, or M1 I should say, it doesn't matter if it's a K-Series engine, if it's a Chevy LS engine, whatever the engine's going to be, the volumetric efficiency values will be the same. That's kind of the beauty of dealing with a VE-based style system. So let's go in here and take a look. Let's go here to 0 to 500 and set this to 100 as well there. Okay, so what we're going to do here is take a look at the idle area. I'm going to say from roughly 50 kPa to 0 kPa. This is going to be vacuum, so 0 is full engine vacuum, 50 is about halfway through up to atmospheric. Somewhere in here, 0 to 1,000 RPM, that's about where I'm going to idle at. I'm going to guess that I'm going to be between 50 to 60% volumetric efficiency. Now that's just a guess, but that'll give me a good starting point. So I'm going to put a value of 50. We should see if everything is correct within our fuel modeling and everything else is in order in terms of properly calibrated air temp sensor, coolant temp sensor, so our charge temp is calculated correctly. We've entered in all the other information. We should find that anywhere between roughly 40 to about 55% VE is normal for idle conditions. Now we actually can take a look at what the inlet mass flow is showing us. That'll give us a good idea if the values that we have in here are going to be reasonable or not. So I'm going to start off with a value of 50. That'll work for pretty much any engine as a reasonable starting point. Now, when I'm here at something like 100 to 120 kPa at 0 to 1,000 RPM, I'm going to set these values to something like 70. And then we're going to go between these two from 50 to 100, and we're going to do a Control H, which is a vertical interpolation. Now, I'm going to take the same value here at 1,000 RPM. We're going to copy it. I'm anticipating my peak torque is going to happen somewhere around maybe 6,500 RPM. I'm going to paste it right.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.